Hey everybody, welcome back to PLC class. So, as per usual, I have come to you with a issue. We are working in a packaging plant that packages various things in boxes. In our packaging plant, what happens is some humans are off on this side of the plant somewhere putting stuff into boxes. And after they are done, they put them in a chute, and the chute follows down here and enters this receptacle area. On the other side of the road here, and this is a road, on the other side of the road here, the same thing is happening. There are people packaging stuff into boxes and sending them down the chute. So here's what we're going to do today. When there is a certain amount of boxes in these two chutes, we want to signal our truck over here. It's in this little truck bay to come and pick up the boxes and load them into our truck. And we don't want the truck to be sitting here until there is enough boxes, because we want the truck to be doing other stuff while we're waiting. But there are a couple issues in that. One, we don't know exactly how long each chute will take. These chutes may produce a certain amount of boxes per a certain amount of time. So maybe in an hour this one does 10. Or maybe it does 10 in like 20 hours. Or maybe it's like 3 days. So we don't actually know how fast these chutes are going to fill up. So that's our first problem. Normally, we would handle a situation like this by just having some sensors and having them attached to a counter in our PLC. And every time a box comes in, our counter counts up, and after a certain amount of counts, we send in our truck, right? Well, we have another issue. Our issue is these two different chutes produce different size boxes. This chute over here, we're going to say, produces 1 meter squared boxes. And this one over here produces 2 meter squared boxes. So we can't use just one counting instruction, because these boxes are different sizes, and we only have, if you look down here at our truck, we only have 10 meters squared on our truck. The truck has a little bit over 10 meters squared. So here is our question today. How are we going to implement a way for our truck to know when we have over 10 meters squared in boxes ready? Well, of course, we're going to have to learn some new instructions to be able to do that. So we are starting today math instructions, which is chapter 11, which is our final chapter that we're going to be studying. You've probably asked yourself many times while you were in school, why am I learning this math? It is for today, because today we are doing math. Okay, let's start by looking at some of our instructions here. So the instructions are under the math tab, the compute and math tab. And we have a couple things here. We have an add, we have a subtract, multiply, division, you know all these, square root, negative. We're not going to jump in these yet, but they're also here. So I'm going to real quickly place some inputs on this thing, and we'll go and we'll explore what these things can do. So I've added some inputs here so that we can control these things on the side a little bit better. So what I've done is also taken away the multiplication and division, because we will get to that in a minute. And also you'll notice I have a timer on delay and a count up counter right here. This is to help us demonstrate the word level addressing that we're going to be able to do. So these things work on the same principles that we have been looking at for the last couple of weeks, and that is word manipulation. That is to say that anything that is a word, like this timers, ACC right here, like this timers ACC, can be manipulated as long as we assign it to this timers ACC. So let's jump right in with these add and subtract. Okay, so addition. We know what addition is. It's 1 plus 1, right? So I can take any word value from my source A. I can take any of them. So let's actually start with an integer value. Oops, that's control. Let's start with an integer value. I will pick an integer. Let's just say n0. Integer 0 right there. so I'll just pick an integer. I'm going to actually use, let's do integer 7, or in7 for the data file, and we will use integer 0. Let's call it 0. Okay, and let's do another one. So in source B here, source B, I'm going to use another integer so that we can define our own integer. I'll use 1. And I'm going to store the value that I get from this arithmetic to our integer 2. Integer 2. So to get it to let me insert values into these, like I can't insert values into these yet, I have to verify, as you do. And as you will see, they've populated these with numbers. And these are all zeros right now, because I haven't inserted anything. So let's say I want to add 2 things. I'm going to add 4 and let's say 6. It's 4 and 6. And I'm going to have it put it into the destination folder right here. The destination data table, I mean. So that is an example in the add, but let's set up our subtraction first before I do anything else. Now, I could use more integers in the subtraction, but I want to show how wacky it can be if you're using your word instructions. As I said before, we can use any word instruction, right? So let's actually use something from up here. Let's say that we want let's say we have a count up instruction. I'm going to take the ACC of this count, and I'm going to subtract the ACC of this timer on delay. And I'm going to actually take that value and I'm going to put it back into the counter's ACC. So I'm going to take this ACC value and I'm going to subtract it with this timer on delay and then put it back in the destination folder. And let's just see what happens. So before I can do that, I need to verify, and I need to go here to this timer, and it will not time unless if I give it some time. So let's give it some time. Let's change the preset on this one too, just for fun, even though it doesn't really matter. Okay, I'm gonna download this thing. Okay, we are now in run mode. Let's do the add instruction here first. Let's do the add instruction. So first off, we're gonna let's bring up our integer file here. Our integers right now have the numbers 4 right here and 6 and 1, and we're gonna add those two numbers together and put them in 2. Put it in 2 right here, which is our destination. So let's see what happens. I'm gonna toggle bit right here. All right, 4 plus 6 into 10. Let's look at our integer data table right now. Ah, yeah, look. Our 10, we have added 4 and 6. Cool. Simple enough, right? All right, let's look at our subtraction. Now, this is going to be a little crazy house. It's going to be a little bit of craziness because I have taken an ACC of this CTU right here, and we're going to subtract the accumulated value of this timer, and then we're going to put it back in this ACC. So let's see what happens here. I'm going to turn the timer's on. So the timer's coming, and it has gone up by 1, and now I will use the subtract instruction. See what we do here. All right, wow, look, this number is growing very quickly, or shrinking very quickly, I should say. It's going into the negatives, and it is going exponentially faster as this value goes up, because it is minusing that from the value that it puts in the top here, and then it puts that value back in. And so as you can see, the ACC here is still moving. The point of that is to realize that we can use, as I've said before, we can use any word. We can insert any word to any of these. And that means we can even insert things back into themselves. Okay, so let's look at the multiply and divide instructions. Well, these are, of course, multiplication and division. And you know about these. So I'm going to actually use the same integers that we used for the add earlier and just see what happens here. And so let's actually do one of these. Let's go to our integer table, and we're just going to drag and drop because we are lazy. Good. We'll add it to 2 here. Okay. Now for the division, I'm going to do a similar thing. I'm actually going to go ahead and take, let's actually take our integer 1 right here, To show another way I can utilize these things, I'm going to actually just divide it by. I'm going to divide it by a flat number. I don't have to set an integer to do these things. I can divide it by a flat number, and for the purposes of learning, I am actually going to divide it by something that it is not perfectly divisible by, which is 5. 6 will not be perfectly divisible by 5. And then we're going to take that and we're going to put that in 3. 3 right here. Put that in 3. Alright, let's download this thing. Alright, we're downloaded. Alright, let's check out this multiplication. So 4 and 6, and we're gonna multiply the 4 and 6 together, and we're gonna put that in our destination. So let's see what happens. Download it. 24, and we look at our integer table, and look, it's 24. It is saved 4 times 6. Okay, so let's do our division. So remember, our division is 6 divided by 5. So, and it's going to store that value in 3. Now, as you know, 6 will not evenly go into 5. So let's see what happens. Okay, let's look. It has stored 1. That is because 5 will go into 6 one time, but it still has a remainder. And integers cannot be numbers that are decimals, right? They cannot be fractions either. So it knows that it can only go one time, and so it stores that value in there. It does not account for our remainder. It does not account for our remainder at all. So that's something you have to realize when you use the division, is that it doesn't work with our remainder. So there you go. That's our multiply and division, and our addition and subtraction. It's fairly simple. You just take source A and do something with source B, and then you put that somewhere. All right, let's go back to our previous example and see if we can fix this problem now that we have the right tools. All right, so we're back at this drawing. So upon further examination, I realized that this drawing was a little bit misleading for what I wanted. So I've tried to draw it out a little bit better. So that this side releases boxes that are 1 meter by 1 meter in size. That's 1 meter squared. And why earlier I said 2 meters squared. What I meant was 2 meters by 2 meters. That means 4 meters squared. So these boxes are 4 meters squared. And we are trying to signal our truck when we get enough boxes to fill up part of the truck. Or 5 meters by 2 meters squared. So we're trying to get enough boxes. We're trying to signal our truck when we get enough boxes to fill up this black area. And we have a little bit of red here, just in case our boxes are a little bit bigger than our truck situation. So that is what we're trying to do. Alright, so I've set up some of the base pieces for the PLC program that we're trying to make. I've set up the 2 sensors, one on each side of the, one for each chute, and a counter connected to that chute. And also I've set up a truck signal, which may be some sort of light or an alarm or literally anything that we want it to be, right? So what part of this should we set up first? Well, let's set up our in condition. Our in condition is to signal the truck when enough boxes have been made to fill a 5 meter by 2 meter space, right? Enough boxes for this. Okay, so let's do that. So I think the best place to start with this is backwards. Let's start at our in condition. Our in condition will be when we have over 10 square meters of space taken up, of boxes. So let's do a comparison. Let's use a comparison instruction for that. So we want this to be greater than or equal to B, right? And so it needs to be greater than or equal to 10, right? 10 meters squared. All right, so let's start looking at the next part. So I think we should store our source A as an integer. So let's find an integer. Let's call this integer 1, and we'll store this value that we're going to compare in integer 1. The data file of integer 1. So the next thing you might think we should do is add up our number of boxes, right? and I think that's a pretty good start. So let's add up the number of boxes we have. So the best way to do that is with our new instruction, our add instruction. We can add the number of boxes we have. And the way we would do that is we would simply take two sources. We would take the accumulated value of source A and the accumulated value of source B, and then we would add them to a destination which we are using as our final destination in 7.1, right? Well, if you look at this, this is actually good, but it is not entirely correct. So as we look back at our diagram, we notice that these boxes are in fact not the same size. So we can't just add these boxes, these number of boxes, and this number of boxes. We will get a completely different number. We will get a completely different number of boxes depending on what boxes we use. So the question there is, how many more is this box worth than this box right here? Well, 1 meter times 1 meter is 1 square meter. So a 2 meter by 2 meter box is 4 square meters, right? That means that this is 4 times as much as one of these. And that means that will take up 4 times as many slots in our truck right here. So to get the right number of footage here, we will have to multiply this counter that this is coming from. So we decided that this counter produces 4 times as much space as this one right here. So we can use one of our new commands, our multiplication command. Let's first add a rung. And let's go back to our computer math. And we will add a multiplication. In fact, I'm going to move this above here, just because I think that makes better sense. Okay, so we're going to multiply this accumulated value, right? We're going to multiply this accumulated value by what? By 4, because it is 4 times as much. It is worth 4 times as much space. And for our destination, well, we don't have anything assigned yet, but we can assign something. And I'm going to assign it to N7 0. I'm going to use an integer table. I'm going to use 0 for our integer table. So now that this will take the ACC of this, multiply it by 4, and store it in an integer. And if we want to use that integer for this add function, then all we need to do is replace. All we need to replace is our source. So this will add source A, which is the ACC of this, and source B, which is this integer value that we derived from the ACC of the second one. Okay, let's see how this thing works out. Verify project, and I will down. Okay, we're online. So right now, all these values are 0, as they should be, because we haven't done anything with them yet. So let's flip a switcher. We'll send a box down the chute. I'm going to send a box down chute 1. Alright, so our counter has went up by 1. And our accumulated value has also went up by 1. Well, that's the same thing. So our accumulated value has went up by 1. So it's taken this value, 1, it has added it to 0, and it has put it in our destination of 1 right here, which is the same destination as this one. And since 1 is less than 10, this does not come on yet. Alright, let's see if our other sensor works this way. Talk a bit. Okay, so this sensor is went up by 1 as well. But it has taken this 1 from this sensor accumulated value and multiplied it by 4. So we've taken the value 1 times 4 and we put it in the destination value of this integer 0, which is down here. So we are adding, with our add instruction, 1 to 4 to get 5. And 5 is less than 10, so our truck has still not gotten a signal yet. Alright, let's add some more boxes. Let's add one more from up here. So we now have 2 boxes in the chute, through the chute. And we're going to add one more from right here. So this is 2 big boxes. So we have 2 small boxes and 2 big boxes. We still only have, we have 8 square feet of of big boxes, and we have 2 square feet of small boxes right here. And it's added these together, and it's gotten 10. 10 is less or greater than or equal to B. So 10 is greater than or equal to 10, I should say. And so our truck now has a signal, and they will come and get the boxes. And they will have the right number of boxes to put into the truck to be able to almost fill the truck up. Just like now, our PLC sees that there are 2 big boxes and 2 small boxes. Let's look at another combination. Okay, so let's edit these. I want less big boxes. I want 1 big box, which will give us a total of 6. And I want let's say 6 small boxes, which will give us a total of 10. So our program automatically understands and figures out and is smart the exact square footage that we need. So now if we have 6 small boxes and 1 big box, it still fits in that truck and be perfectly fit. So that's the power of our multiply and add instructions. And along with our division and subtract, which we didn't use here, but they follow along the same idea. If we're using math, we can make smart decisions about what we're doing. We can make smart math decisions about what we're doing. And this is the power of adding a math instruction. Just try and do that with motor controls alone. It would not be very easy.